All right, here we go. Question number 10 from our 0314 homework number 6 in MyLab Math. And the instructions want us to add, it says simplify by collecting like radical terms if possible. So what you need to know about adding radical expressions together, two things have to happen, okay? First of all, if you want to add radicals, they have to have the same index. And so notice that both of these radicals are square roots. They have an index of 2. So their indices, yeah, the roots match. And in order to add radical expressions, they have to have the same radicand. In other words, they have to have the same stuff underneath the radical, which these don't. And so my job, let's see, like Mission Impossible, my mission, should I choose to accept it, is to try to get these radicands to match, okay? Here's how we're going to attempt this. We're going to try to break these numbers down into factors where one of the factors can be square rooted, okay? So our first job is to find factors of 27. That means numbers that multiply to make 27, one of which is a perfect square. And I hope it doesn't take you too long to come up with 9. What am I doing? Writing a 2. 9 times 3. 3 times 9 is 27. Notice that 9 can square root. 9 is a perfect square, okay? Now, for the second radical, we're going to try to come up with factors, numbers that multiply to make 75, one of which is a perfect square. And again, I hope it doesn't take you too long to come up with 25 times 3. 25 times 3 is 75. 25 is square rootable. 25 is a perfect square, okay? So now the 9 and the 25 are going to get to come out from under the radical because they are square rootable, okay? So this 9 comes out and becomes a 3. Notice there was already a 3 out there, and those 3's are going to multiply. Okay, for the other radical, the 25 comes out as a 5. Square root of 25 is 5, but there was already a 5 out there, and so those 5's are going to multiply. Okay, one more time. The square root of 9 is 3. That's where this 3 comes from. And then this 3 was already there. That's where that 3 comes from. The square root of 25 is 5 here. This 5 was already out there. That's where that 5 comes from. Okay, so now I need to multiply. 3 times 3 is 9, square root of 3. 5 times 5, we have 25, square root of 3. And now if you look at my radicals, those are now identical. They have the same index and the same radicand, which makes these like terms. And to add radical expressions, you simply add their coefficients. 25 plus 9 is 34, and the square root of 3 comes along for the ride, okay? So that should be my final answer. Wouldn't it be nice if there was some way that we could check that, maybe with technology? Well, let me introduce you to my Casio. The Casio Class Whiz will actually do this problem for you. You can simply type in the problem just the way it looks at the beginning. We have 3 square root of 27 plus 5 square root 75. And if you hit equals, look at that. Does all the work for you. But I am showing the work in case your professor requires you to show work, okay? If he wants to see the work, which it would be nice to see that you understand the process, and then simply use the calculator as a checking tool. Here we go. 34 square root of 3. Bam. All right, so I hope that was helpful. If you have any questions or comments, feel free to leave those in the comment section below, or you can text me. And thanks for watching.